Hello, programmers. So, congratulations. I hope by now you have completed two of your projects. And in this third project, we will be working on Tic Tac Toe. Again, every one of us knows what is a Tic Tac Toe. And I don't need to tell you the rules and how the game is played. But here, in this introductory section, I will just show you of sort of demo of this game that I played with it. And you can see here, I think one represents the user and the -1 represents the computer. So initially I made the move. So you can see, please make a move. I selected 5, and you can see these all these 9 squares are actually numbered from 1 to 9. So 1, so this is the 1, 2, 3, 4, and 5. So when I selected 5, so the value of the box here at the position 5 changed from 0 to 1. And correctly, if you have guessed, the computer's move was 9, and therefore the value of this particular square changed from 1 to -1. Then that it was again the user's turn, and so I chose the move 2. So you can see it here, the value changed. The computer's move, it chose the very first box, and the corresponding change in the value, you can see it. Then again it was the user's turn, and I chose the value 8, which is here, and that would just make that you can see here I have won the game clearly, and therefore the computer did not uh, get the next chance to make a move because the game is over since I have won. So that was a quick demo of how what this would look like after you have built this game. And let me show you the code. So this is the complete code and the different methods. It will help us to achieve it. You can also see we have a bunch of modules here that we would require in our project. So I think that was a good introductory section, and I hope to see you in the next one. Hello, programmers. So, in the previous section, I gave you the introduction to the project, and now I will dive deeper into this project, Tic Tac Toe. So, let me just first connect and notebook. So, so you can see now here we have some interesting imports. So, let me just walk you through them. So, first, tabulate. So tabulate actually will just help you to present our scoreboard in a very much good way, and not just represented by a simple list. So what you can see here, down here, this therefore this will help us to represent the table in a board like format and not just a simple list. So it just gives a better representation to the project. Then let's come here to numpy, and some people also call it numpy, but numpy stands for numerical python, and it's a great module that yeah, I think you should know if you want to go ahead, especially into data science or machine learning. It will be of a great help for sure. Then if we come down, import a random, the random module, you are already aware of this module from the previous two projects, and as we know, it allows us to generate give use some uh, uh, elements that are randomly generated by the computer. Now, if we come back here, import math, so it will be just used to for uh, some important math elements that we would require in our project. So that's it. Let me execute. Yeah. So now we can come here. So you can see I've defined this method here, display method, that takes in one array, which is nothing but numpy array, as you can see it here, and it serves as the board. So we are using a numpy array as our board, and numpy array is nothing but just think of it as a sort of list, but it's more easier to work with numpy, and it's a better way to work with your code using numpy array than the list. And and uh, uh, there are various functionalities that NumPy directly provides you. So rather than using list and coding those functions by yourself, NumPy saves your time. So it's a great module that you should know. Now this method display returns none, because as I think you might have guessed, the display method just displays our board. So now the tabulate module comes into the picture. So as you can see, the tabulate method takes an R array, which is given to the method, and this is the table format argument, which is just there are various arguments that you can give to this. There are various strings like this one that you can give to the table format argument, and you get the corresponding output. So I tried to keep this simple board for us using this argument here, and now you can feel free to experiment with this. So let me just execute this method, and we have executed it. Now we come on here and we actually use this method. So as I told you, there are 9 squares here in the board, uh, and accordingly, actually, I have numbered them from 1 to 9. So, and how I have done that? I have done it using NumPy. So this is NumPy dot space, which is linearly spaced. So, and this is the starting point 1, this is the ending points, and this is the number of pieces I want. So from 1 to 9 I want 9 numbers, so that has to be 1, 2, 3, 4, 5, 6, 7, 8, and 9, and then I directly reshape them into 3 comma 3. So it's not a simple row vector. In fact, it's now 3 by 3 matrix, and I have passed this matrix of 3 by 3 to display method, and as you will recall, it required one array, and this is the array that we pass on to the display method, and which in turn is displayed by the display method here, as you can see. So let me just execute it, and you can see it here. So the table above displays the board of the game with each square and its unique value. The user and the computer can select any unoccupied square by choosing the corresponding numerical value displayed above. initially all the values in the board are set to 0. The value of the square selected by the user is changed to 1, and the one which is selected by the computer is changed to -1, right? So now let us come back here and let's go through another method. Now, when a user makes the move, it's important to validate that move. So uh, it should be a valid move, right? So, and that's what is accomplished by this method, make move. Okay. So again, this takes two arguments, a number and one array. So number is one integer value, and definitely, as you might have guessed, again, this integer value denotes the particular square in the board, and the array is the board itself, right? Now what it returns? It returns the updated array. So whenever the user selects the particular square, the value is changed from 0 to 1, and the updated array is returned back. So let us come down into the code. So for the very first, in this very first statement, we check if the integer value given by the user is less than 1, and it is and it's not uh, greater than 9. So if it is less than 1 and or it is greater than 9, definitely it is an invalid value, because our board has only 9 possible 9 squares, and therefore only 9 possible values. So if the user input is less than 1 or greater than 9, it's an invalid move, and therefore we print this statement that the number is outside this given range, so that the user knows that he or she is supposed to give the input in this particular range. And after saying that, we just return the array, and the function is executed. Now, for suppose if the user has given a valid value for the number, which is the uh, integer that denotes the specific square of the board, then what we do is we just subtract 1 from it, and we do mod by 3. So this mod operation here, which is sort of this percentage sign, actually returns the remainder. So for 2 mod 2, it will return 0, because for that operation the value 2 is completely divisible by 2. So we do that to actually get the column value, because remember we had uh, a 3 by 3 array as our game board. So if we want to access the values, we would need the column as well as the row value. So, and therefore in this next statement we get this row value by using math.floor, which is again to restrict the value, and we just do again the division here by after subtracting 1 from it. And this is the simple logic to get the value for row. You can try it yourself, you can take a pen and paper, and if you work it out, you will find that it works well. And if you are confused with the numpy array, let me show you it here. So for example, if we use array example np dot zeros, and let me give it a shape. So this will return an array of the defined shape with all the values as zeros. So let me just keep it 3 comma 3, so it has the same shape as our game board. Now I have defined it, and let me just print it. So I've executed, and that's an error. Array example is okay. I'm sorry. So you can see this is how the array looks actually, which is the another 3 by 3 array. So this is this something. This is the same thing that our board actually looks like without the tabulate module. I think you get a good idea of how it would look without the tabulate format. So now if I want to access a particular value, for example, I want to access this first element 0 here. So I can do here array example 0 comma 0. You can see 0 over here. Let me just change it because all of the elements are actually 0. So 1. So so 0 comma 0, which is the first element, I have changed that value to 1. And if now I print array example, you can see the first element is changed. So I actually accessed the first element. And now let me tell you, the first argument in here, the first 0 here actually denotes the row number. So this is the 0th row here, this one 0th row, and this second argument here denotes the value for the column. So this one, this is the first column here. So this is the first column, and this is the first row. And remember, indexing always starts from 0. So the first row has the index 0, and that's how things work in Python. So I hope you are clear with this array concept here. Let's move ahead. So in recall that in this method def make move, we have already seen up to row. And if you are not clear with this logic here, I would really appeal you to take pen and paper and work these things out. Give some random values to this num variable, and you will see that it gives the correct row and column for the corresponding integer value that the user has chosen. So after we are done with that, we another thing that we need to see that if the square is occupied or not in any of the previous moves. So if the array of row and column is not equal to 0, so recall again that if the user or the computer has chosen any of the squares, the value will be the value of that particular square will be either 1 or minus 1. So if it's 1 or minus 1, it means that the square is already occupied in any of the previous moves. So therefore, that's what we do here. So if the value is not equal to 0, then we print that the square is already occupied, and we return the array. And the function is executed there itself, right? Now, if the square was previously unoccupied and the value entered by the user was a valid value, then we change the value of the of array or nothing but our game board as 1, because our 1 actually represents the user, the square of the user, right? And again, notice that it's the same thing that I just showed you with our example array. So it's that simple. And then we return the array and the function is executed, right? So I hope you got that. So in this video, in this section particularly, we had a look at the different modules, this display method. Then we had this little session of NumPy, and there are various methods with NumPy like np.once, np.I, np.linspace, logspace, np.array. There are a lot of things. You can refer NumPy documentation if you want greater detail into it. Then we also saw here the make move method, which is responsible to validate the move of the user, right? And we saw the entire logic here. And in the next section of the video, we will go further and have a look at the other methods present in our project. Thank you. Hello programmers. So in up to now, we have seen up to this method make move, which is responsible for the to validate the user move. Now let's go to the computer. So after the user has made his or her move, now it's time for the computer to make that move. So and that's what this method does. It is responsible, it's actually, it helps the computer to choose a particular square, and then it also changes the value of that particular square from 0 to -1. So the only argument that the method takes is array, which actually is our board game. Then it returns a number integer, the integer value which is selected by the computer. So the user should know which value was selected and if it's the actual value which is updated. So he or she should not feel being cheated in the game. So that's why it returns that integer value, and definitely it will also return the updated array, which is our game board. Let's go here now. uh, Again we use a while loop here, and while true means that definitely the while loop will be executed. So therefore Python is compelled to go into the uh, loop body. And so now we go here, and in the previous projects we have come across this element of the random module, which is rand int, and it samples a random integer in the specified range. So here the specified range is 1 comma 9. So we have 9 squares, and therefore this range. So we get one value uh, randomly picked in this range, which is stored in this variable num. Again we use the same logic as in our previous make move method to get the column value and row value that we would require to access the element of our board game. Now again we check if the square is occupied, and now here I use a little different way of doing the same thing. So if you recall what you can see here, to check if the square is occupied or not, here I used if array of row comma column is not equal to 0, then print the square is already occupied. I executed the function then and there, And if that was not the case, then I updated the value here. But for the computer turn, I am not doing that. I am directly checking if the array uh, array value is 0 or if it's 0. So row and column are used here to access the value, as I told you. So if this particular value is 0, then I will update the value as -1. And why I do that? Because it makes no sense to let the computer know that uh, it was uh, the value it had chosen previously was already occupied, right? And definitely the user doesn't really care about that, so there is no point in just unnecessarily printing that statement. So therefore I directly used this if statement here and updated the value here, and and then use this break keyword to break the loop, and just assume that if the value was already occupied, then this condition was not true. So the Python will again go back to the first line. Definitely this condition will always be true. So again it has to come here, and it will again randomly select a integer value in this range, and the corresponding statements will be again executed, and it will keep on executing until it has found a value, that a particular square that is yet unoccupied, right? So I hope this compute comp turn method is clear now. Now let us go to another method, and I think it's the longest one I think you have seen so far in this in these three projects. So this is the method validate, and as the name suggests, it validates the winner in a particular game. So again, it takes only a single argument, which is array, which is nothing but our board game, and it returns 0 if any of the winning condition is satisfied by any of the player, or else it returns 1. Now let's go into the logic. Now we define this boolean variable, which is named to be flag, and we will make use of it as we move further. And before anything else, we check this possibility of a draw. So if all the elements are taken, none of them uh, is 0, then definitely it's a draw. And since none of the condition was met in the previous move, none of the winning condition for none of the player was met in the previous move, so it definitely means that it is a draw. So therefore we just print it's a draw, and we change the value of the flag to false. Okay, now we come down, and let's say if the user has won, and the user has won for the particular condition of the principal diagonal, so the diagonal that runs from the top left to the bottom right, and all of those values of the diagonal has been occupied by the user. It means that the user has definitely won, and that is checked by this condition here. So note that these values in the square brackets denote the row number and column number, and if all of them are 1 here, it means that the user has won for this particular condition. So we print the same thing, that the user wins the game, and we change the value of flag again in this case. Now we check the same condition for the computer. If the computer has won for the same condition, similarly we check for the another diagonal condition that runs from the top right to the bottom left, and again we check it for the condition if the computer has one for that other diagonal condition. So after we have checked all of these diagonal values, the flag comes into the picture. So if not flag, so remember that if any of the above condition is met, the flag is false. The value for the flag is false, and if not flag means if true. So the condition will become true here, and it will return 0, and the function will be executed then and there. So it will be complete at that point. But for suppose if any of the condition is not met here, this condition will not be true. So this if block will not be executed, and we would go further here. So this is the if true condition, and it means that this is true. And for here we use the for loops to check if any particular row is conquered by the user, and we use this simple logic for that. So this is the list, and we use a for loop to traverse through the list, and we check if this is the array index. So initially the first value it will take will be 0. So array of 0 comma list here. So this is array of 0, and that converted to list, if that is equal to 1 comma 1 comma 1, then it means that the user has conquered the first row, the 0th row, and the user will win. Similarly, we will check the condition for the first and second row, and the very same logic can be used to check the condition for the computer. Uh, this if any of the row is conquered by the computer, and again we can use the same logic to check if any of the column is being conquered by the user or the computer, and that's what we do here. And in these two columns, right? And as soon as any of this condition is met, we directly return 0, and the function is executed then and there, right? And again, if all of these conditions are not met, we return 1. So if any one of you is confused about the logic used here, let me just go back to the example of the array example that we used in the previous section. So if I do array example of say 0, this is what we did in the condition for the rows, and let me see what it returns. You can see it returns the first row. You can see it here, right? 1 0 0, which denotes the first row. And if I do the colon and the comma, it means this colon denotes that all the rows of the 0th column, right? So this should return me the first column here, 1 0 0. And again you can say that there doesn't seem to be a much difference here. So if I show you back here, it looks the same as the previous one. So let me change one element, so I can change 0th row and column number say 1 to 1 here, say. So let me print the array example again. So you can see the value has changed here. So now if I do array example of 0, you can see 110, right? So this represents the first row here. And now if I use the colon here, so you can see 100, which is nothing but this column right here. So I hope that makes sense. And actually this colon is used uh, to take on a particular range of the rows or columns. So you know that the first value corresponds to the rows and the second value corresponds to the column. So if I say I just take 0th row to the second column and the 0th row to the second column, sorry, so this is 0th row to the second row and the 0th column to the second column, and note that this is exclusive of this. So if I do this, you can see we got a 2 by 2 matrix and not 3 by 3. So we just got this. Sorry, I am not able to highlight, but I hope you get the idea, right? So I think that's it, and I hope that can help you to understand the logic that we used here. And definitely I encourage you to try some stuff with NumPy arrays and the logic that you see here. And if you are already someone familiar with these topics, take a step forward, increase the complexity of this project, and develop something more good. And I hope to see you in the next section where we will see how all of these methods come together to build to complete our project. Thanks a lot. Hello programmers. So now I welcome you to the final section of this playlist as well as this video, and here we will see how all of the methods that we saw previously come together to help build and complete this project. So at the very beginning I just defined this variable flag, and I know I have used a lot of variables named flag in this playlist. I'm sorry for that. And then we come here, we define uh, we define our board using this np.zeros method, and recall that it's the same method that we used to declare our example array in the previous sections. So now again we come here to the while loop, and as I have told you a lot many times in the previous projects and also in this video in this particular uh, for this particular project, we while true and while one is one and the same thing. So the value of the flag is 1, which denotes that this is the true condition here. So the Python is bound to go into this into the body of the while loop and execute the corresponding statements. So here we take the integer input from the user because uh, the user needs to give one of the 9 elements, right? One of the 9 numbers, so that we can update our board, and then we can take the value from the computer. So once we get the input from the user, we store it in the variable user move, and then we use the make move method to validate the move of the user, and it returns the updated array, as you may recall. And let me execute these. I think I have not executed these methods. And validate now. Yeah, so you can see def move method, which returns the updated array. So this updated array is nothing our board, so we take this updated value in our board variable. Then we check for if any of the player has won, right? And this validate method, remember that it returns 0 if anyone has won, and if none of the players have won the game so far, it will return 1. So if the condition has met for any of the players, this will this flag the value for this flag variable will be 0, which in turn denotes false. So if not flag actually denotes if not false, and the negation of false is actually true. So if true means that the Python will execute this if block. So it will use the display method that we saw in the second section for this video, right, which will display our game board, and it will also allow the user to know which move he or she had chosen. So if the user presses key by mistake, the user still knows what was the move which was accepted by the program. And then we break, right? So the user has won definitely, and therefore the game is over. Now for suppose this validate method returns 1, and that means that the none has yet uh, won. So this condition will not be true, and we will come here, we will check for the computer toy, right? So this checks if the user has won, and here we if this code or this if block was not executed, it means that the user has not won yet, right? So now we will take the I will ask for the computer to make its move, and the comp turn, as you can recall, returns two things: the numpy integer, which denotes the value selected by the computer, and the updated game board, which is nothing but a numpy array. So now again we use the validate method to know if the computer has won. So we are using this validate method separately for the user and the computer, right? So at the beginning here, we are just checking if the user has won, right? And now here, we are checking if the computer has won, okay? And again, the same goes with it. The value for flag can be either 0 or 1, and we will again definitely display our board using the display method. We will print the move of the user, we will print the computer's move, and now again we will check for this condition. Again, if the computer has one, the value for flag will be 0, so it will be if not 0. 0 denotes false, so it will be if not false, and not false actually is true. So it will be if true, and if true means that we will just break the while loop, and the this particular cell will be executed, and it will be the end of the game and the program as well. But consider that the computer has not won, so that would mean that we have none of the players as the winner yet. So therefore this block will not be executed, and Python will jump back to this while loop, and definitely the flag is still 1, and 1 denotes true. So while true will be the condition over here, and the Python will again execute all of these statements, and these statements will be kept on executing until either the user or the computer wins. Okay, and that's it.